Good evening, everyone. Can you hear me in the back? Yes, okay, thank you. It's a tremendous honor and a tremendous pleasure to be here with you this evening, to be the recipient of the BBVA Foundation's 4th Biophilia Award, and as I now understand it, to be delivering the first of the speeches in person. It's really a tremendous honor. The BBVA Foundation supports amazing work all around the world in all sorts of fields, as you've heard, people working at the cutting edge of science and on the most pressing problems of our time. So I want to thank the foundation. I want to thank the members of the jury who are here, the members of the jury who are not here, and the many distinguished guests who are here this evening. So the title of my talk this evening is Man in the Anthropocene. And I wanted to start by introducing this word, which has become essential but didn't exist as recently as a few decades ago. It was coined in the year 2000 by the Dutch chemist Paul Crutzen, who a few years earlier in 1995 had won a Nobel Prize for his work on identifying ozone-depleting chemicals. So in 2000, Crutzen was attending a scientific meeting in Cuernavaca, and participants at the meeting kept referring to the Holocene, the geological epoch that began at the end of the last ice age, roughly 12,000 years ago. We are no longer in the Holocene, Crutzen told his surprised colleagues. We are in the Anthropocene. The term is, appropriately enough, a mashup of geological lingo and Greek. And what Crutzen wanted to convey with it is that we have entered a new geological age in which humanity is the dominant geological force on the planet. That is an epochal change of really unequaled magnitude. In the Anthropocene, in the age of man, people are still, as they were in the past, subject to nature. We see this all the time, every time there's a flood or a heat wave or an earthquake. But the weird thing about the Anthropocene is that nature is also subject to man. So in 2002, Crutzen wrote a short article about the Anthropocene that appeared in the journal Nature. And in it, he pointed out that the signs of the Anthropocene are everywhere. And here, I'm just gonna go through a couple of them, a few of them. So humans have directly transformed more than half of the ice-free land on Earth, some 70 million square kilometers. We've done this by building cities and suburbs and reservoirs, and also by cutting down forests and planting monocultures. And we have probably indirectly transformed about half of what remains by putting in laying pipes and seismic lines and logging roads. We have dammed or diverted most of the world's major rivers. People now cause more soil erosion than all natural processes combined. In our fertilizer plants, we fix as much nitrogen as all terrestrial ecosystems combined. And this effect is being felt not only on land, but increasingly also in the oceans. Every summer, for example, a huge area of low oxygen, so it's known as a dead zone, opens up in the Gulf of Mexico. This is a direct result of fertilizer runoff. These dead zones appear all around the world, and they are unfortunately growing. Humans now outweigh all wild mammals, all of them, by a factor of roughly 9 to 1. And if you add in our mammalian livestock, so that's mostly cows and pigs, who weigh a lot, that ratio climbs to 24 to 1. So we humans and our livestock outweigh wild mammals 24 to 1. We are transforming the climate, which in turn is melting the world's ice sheets, altering its coastlines, and even changing the tilt of the Earth's axis. In the age of man, there is nowhere you can go, and I really mean nowhere, where you will not find evidence of human activity. when Japanese researchers descended to the bottom of the Mariana Trench in the Western Pacific, so to a depth of more than 10,000 meters, this is what they found. That's plastic debris at the bottom of the Mariana Trench. So I began writing for the New Yorker magazine right around the time that Paul Crutzen went to Cuernavaca. And for the last 20 years, most of my work as a journalist has been devoted to documenting the Anthropocene. My reporting on our changing world has taken me all around the globe, to the top of the Greenland ice sheet and the southern edge of the Great Barrier Reef, to the Mojave Desert and the Amazon rainforest. I've interviewed scores of scientists who are working to understand human impacts on the planet. These include geographers and glaciologists, oceanographers and ornithologists, conservation biologists, and climate modelers. And even after all this time, all these conversations, all these reporting trips, I still have trouble getting my mind around the Anthropocene. And so do the scientists. Time and time again, researchers I have interviewed have told me that they are seeing change on a scale and at a pace that they were taught in graduate school could not be witnessed, could not take place in the course of a human lifetime. Time and again, they've expressed to me shock and horror at their own discoveries. Some have watched their study subjects, be that a species of frog or an entire glacier, disappear in the course of their career. One scientist I interviewed who was working on the effects of ocean acidification told me that when she realized the significance of her discovery, she went into the bathroom and threw up. The general public often sees journalists as overplaying the dangers of the crisis, or if you prefer, crises, that we are facing. They imagine that we are exaggerating for the sake of drumming up an audience, of selling books perhaps, or generating clicks. Would that were the case. In fact, if anything, I would argue that journalists and the scientists that we rely on have tended to underplay the extraordinary changes that are taking place. A few years ago, a group of scientists and sociologists wrote a paper on this phenomenon, and they called it erring on the side of least drama. And if there's one message I would like to convey to you this evening, it is this one. What we are doing to the planet is beyond extraordinary. It defies both conception and description. It is unprecedented in the 3 billion year plus history of life on Earth. In my articles and in my books, it is this hugely important but also very scary message that I have been struggling to get across. But of course, journalists are not primarily message deliverers. Our real business is not piling up statistics as I have just done. Our real work is as storytellers. It's our job to create narratives that people can follow and that people can relate to. And so this is what I'm going to do with the time that remains to me this evening. I'm going to tell 2 stories about the natural world and our increasingly vexed, increasingly crazy relationship to it. And everything that I'm going to relate in these 2 stories is true. None of it is made up. And yet I would invite you to think of both of them as Anthropocene fables, which is to say, as stories that point beyond themselves to larger meanings. So the first story that I want to tell is about a toad. This toad here, which goes by the Latin name Rhinella marina, and whose common name is the cane toad. So cane toads were originally restricted to South and Central America. That's where they were evolved, and that's where, for many, many thousands of years, they remain. And then we came along, we humans, and changed that. And the reason is our love of sweets. Sugarcane, which is a crop that's native to New Guinea, was moved around the world, and starting in colonial times, it became, as you know, a very valuable cash crop. Unfortunately, other creatures besides human also like to eat sugarcane. Beetle grubs, in particular, like sugarcane. And this, farmers found, was cutting into their harvests. And so in the 19th century, someone came up with a bright idea for dealing with the problem. To protect this imported crop, sugarcane, they would import cane toads. And so people started to move these toads around the world. It is very unlikely that the toads ever did much good for the sugarcane crop, but they were moved around the world anyway. They were first brought to Puerto Rico, and then they were brought to Hawaii, and from Hawaii, they were moved most consequentially to Australia. The first cane toads arrived in Australia in 1935, and they were released in northern Queensland, which is in the northeast corner of Australia, Australia's sugarcane country. So this is a map that shows you what happened next. It's a map of how the cane toads hopped their way, first slowly and then more quickly, around Australia. And nowadays, as you can see, the toads are almost as far south as Sydney. They're as far north as the Cape York Peninsula, which is that pointy peninsula up in the north, and they've made it all the way west to the wonderfully named city of Darwin. And they are still expanding their range. So those barred lines you see on the map show what their eventual range is expected to look like. And this is, in many ways, a typical Anthropocene story. Brown rats, just to take one example, should be restricted to Central Asia. And now, thanks to us, this map is showing you their global distribution. They are now everywhere. The European green crab belongs on the Atlantic coast of Europe. That's where it evolved. Thanks to us, once again, it can now be found on both coasts of the US, on the southern coast of Australia, and on the southern tip of Africa. The brown tree snake is a native of Australia and New Guinea. It was brought to the island of Guam, probably during World War II, and it has driven many of Guam's native birds to the very edge of extinction, some of them over the edge. So moving species around the world is something that we do now all the time, and we're accustomed to it. It seems very normal to us, an ordinary part of everyday life. Many of us have deliberately planted non-native species in our gardens. Many of us keep non-native species as pets. But in fact, of course, when you think about it, when viewed in the context of evolutionary history, there is really nothing normal or ordinary about moving plants and animals around the world. It's a very new phenomenon. Without humans to help them, no cane toad could have crossed an ocean, and no aquatic species could cross a continent. When we move species around the world, we are bringing together evolutionary lineages that have been separated for many, many millions of years. And in a way, by doing this, we are running geological history backwards and at a very high speed. So around 250 million years ago, all of the world's land masses were squished together into what geologists call a supercontinent, the supercontinent of Pangaea. And then, owing to the marvels of plate tectonics, the continents drifted apart, and we got the world as we know it today. But by bringing together all of these lineages that evolved separately, we are, from a biological perspective, bringing the continents back together. And some biologists have said that we are creating a new Pangaea. So to go back to our friends the cane toads, for toads, cane toads are very large. This is a cane toad that was just recently captured in Australia. It got a lot of press in the country and became known as Toadzilla. Cane toads are, in some people's eyes, ugly. I'm going to leave it to you to decide that. For sure, they are poisonous. Cane toads have two glands, one behind each of their shoulders, where they store a milky-colored toxic goo. In its raw form, this goo is potent enough to make an animal or a person sick. But when the toads are attacked or they feel threatened, they produce an enzyme that bumps up the potency of this toxic 100-fold, so by 100 times. So in many cases, invasive species are a problem because they are predators. For example, in the case of the brown tree snake, and they prey on the native species. With cane toads, the problem is the reverse. To a lot of Australia's native animals, cane toads look like an easy dinner. These animals try to eat the cane toads, and generally, they wind up dead. As I mentioned before, it's unlikely that the cane toads ever did Australia's sugarcane crop much good. But the spread of cane toads has been an ecological disaster in Australia, which, precisely because it is so isolated, has a very unusual and hugely interesting fauna. There are many, many species that live only in Australia, and Australia also lacks whole groups of organisms. And one of the groups of organisms that it lacks are toads. So there are no creatures in Australia that evolved to evolve with toads or to understand, evolved with what we'll call an understanding of the dangers of poison toads. And that is why, to many native species, the toads look so tasty. And the list of species in Australia whose decline has been linked to cane toad consumption is long and varied. It includes several species of snake, several species of giant lizards, and perhaps most notably, this very sweet-looking, but actually very ferocious marsupial, a carnivorous marsupial, which is known as the northern quoll. So Australians have really thrown themselves into the task of trying to get rid of cane toads. They shoot cane toads with air rifles, they whack them with hammers, they bash them with golf clubs, they purposely run them over in their cars, they stick them in the freezer until they solidify, and they spray them with the chemical chloroxylenol. But as the map I showed earlier indicates, this has not slowed down the cane toads. We brought these cane toads in, but we cannot get them out. This is a typical Anthropocene outcome. Humans are very good at altering nature, but when it comes to anticipating the consequences, we are astonishingly careless. We move species around without bothering to really investigate what the consequences may be. Very often, we find we don't care for the results, and we would prefer things the way they were. But by this point, as we say in the US, the cat is out of the bag. It's very difficult, indeed close to impossible, to get rid of a successfully established invasive species like the brown rat, or the brown tree snake, or the cane toad. And so some scientists in Australia are trying a new approach. So this fortress-like building is the Australian Centre for Disease Preparedness. It's situated south of Melbourne in a city called Geelong. And if you've ever seen the movie Contagion, there's a shout out to the center in the film. One of the panicked doctors says that they're going to be sending a sample to Geelong. It's one of the world's most advanced high containment labs. It has 520 airlock doors, and its concrete walls are thick enough to withstand a plane crash, or at least so I was told. One of the people who worked there told me that it was the kind of place where you'd want to be during the zombie apocalypse. So I visited the center because researchers there are at work on a totally crazy-sounding but totally real project of gene editing the cane toad. What they're at work on is inventing a version of the toad that's less toxic, a toad that would not kill quolls or anything else, that eats it. And the plan is to rewrite the toad's genes to disable that enzyme that bumps up the potency of the toad's poison goo. And key to the work is CRISPR. You've probably all heard of CRISPR. It's a technique which humans actually borrowed from bacteria that has made gene editing a lot cheaper and a lot faster. And already, scientists in Geelong have engineered less toxic toads. This is a photo of a CRISPR-edited toad. And these toads have not been released out into the world, but that is the idea. It's very, very far from clear whether this idea will work. But this is the logic of the Anthropocene and why the story of the cane toads makes a good fable. In the Anthropocene, change begets new and even more extreme forms of change. We changed nature when we brought cane toads to Australia, and now we are trying to change it again, engineering a creature that never existed in nature to replace the one that we put there. So this second story, or fable, that I want to tell tonight is about orca. Now, orca sounds like the name of a whale, but in this case, it's actually the name of a machine, or really a collection of machines, which have been installed in Iceland. And the orca story begins all the way back in the 18th century with the invention of a very different machine, the steam engine. By many accounts, including Paul Crutzen's, the invention of the steam engine is what launched the Anthropocene. The steam engine was originally invented to pull water out of coal mines in England. It was subsequently adapted to propel rail cars and tugboats. And in this way, it helped usher in the Industrial Revolution, which in turn increased the demand for coal and eventually other fossil fuels like oil and natural gas. Burning fossil fuels, as you all know, changes the world. And one way to think about this change is again in terms of geological history. Fossil fuels contain a lot of carbon that has been sequestered underground for tens and in some cases hundreds of millions of years. By digging up these fuels and burning them, we are returning that carbon to the atmosphere in a matter of centuries. So here again, we are in effect running geological history backward and at a very high speed. CO2 levels in the air today are now higher than they've been at any point in at least 3.5 million years, which is to say, long before modern humans evolved. And those levels, as you all know, are continuing to climb. The rise in atmospheric CO2, once again, this is something that you all know, is having devastating effects all over the world, and this includes, of course, here in Spain. It is estimated that in Spain alone, 1,600 people were killed in last August's heat wave. Last month, the government of Catalonia announced new water restrictions that will affect at least 6 million people. And just the other day, as I'm sure you've all read about or seen, wildfires in the region of Valencia forced 1,600 people to evacuate. And there's a lot of concern that this summer's fire season, we're only in March now, that this summer's fire season will be as bad as last summer's. I know that the Spanish are very worried about climate change, and I'm sorry to say that you should be, because the situation is only going to get worse, and in many ways, you here in Spain are on the front lines. So this is another instance of the pattern I sketched earlier. By burning fossil fuels, we have, without quite meaning to, changed the world. And now we realize that that change is not to our liking. We would prefer, indeed we desperately want, the climate to go back to the way it was. But how is that supposed to happen? The ancient carbon that we've extracted from the ground and put back into the air is going to stay there, unless that is that someone can figure out a way to suck it out. And that is the idea behind orca. The point of orca is, in effect, to reverse history. So these machines here that look a lot like air conditioners, they're known as direct air capture units. And they work roughly like this. Ordinary air, like what's flowing through this room, what's flowing outside on the street, flows through the units, and inside of them are chemicals that bind with CO2. And when the chemicals are saturated with carbon dioxide, they get heated, and the CO2 is forced off. It's collected, and then it's pumped deep underground, very deep. So the units at Orca are connected to a borehole that's been drilled 2 kilometers into the rock. And once it's 2 kilometers down, That CO2 reacts with Iceland's volcanic rock. All of Iceland is basically, one big lump of volcanic rock, and it forms calcium carbonate. So it basically reacts to form limestone. And here is a rock core. This is a picture of a rock core that was extracted from beneath this operation that shows that vein of calcium carbonate. So shows that what they are doing is, on some level, working. They are successfully sequestering that carbon back underground. So direct air capture would allow us, in theory at least, to put back into the ground the carbon that we've put up into the air by burning fossil fuels. The setup in Iceland is, in fact, already removing CO2 from the air. It's removing it at the rate of roughly 4,000 tons of CO2 a year, which is impressive, at least until you measure it against current global emissions. So current global emissions amount to roughly 40 billion tons a year. So roughly speaking, this project is extracting 1/10,000,000th of the CO2 we are putting up into the atmosphere every year. Or, to put this differently, to remove what we are adding each year would mean building 10 million versions of the Orca project. So another possible way for us to take control of the situation is a technology that's been called solar geoengineering. There are no solar geoengineering facilities that have yet been built, but there's increasing amount of discussion about this technology and more research being done on it. And in the movies, at least, it's already happening. So the idea behind solar geoengineering comes from volcanoes. A major volcanic eruption blasts a lot of sulfur dioxide into the stratosphere. And as that sulfur dioxide drifts around on stratospheric winds, it forms these little tiny droplets, which are very, very reflective. These droplets, or aerosols as they are known, they reflect sunlight back towards space. And the result is that less direct sunlight hits the Earth and global temperatures fall. So following a major eruption, that cooling effect lasts for a year or two until those particles fall out of the stratosphere. And this is what happened after Mount Pinatubo erupted in 1991. The effects of Mount Pinatubo were measured very precisely with modern instruments. But we also have a lot of historical records about the impacts of volcanic eruptions. Mount Tambora, in what's now Indonesia, erupted in 1815. That was a huge eruption, one of the largest in recorded history. And the next year, the year of 1816, became known as the year without a summer. Where I live, in the state of Massachusetts, there was frost recorded in the middle of August. And probably not coincidentally, that was the year that Mary Shelley wrote Frankenstein. She and her husband and Lord Byron had rented a villa on Lake Geneva, and it was cold and rainy all summer long, and so one of the things they decided to do was to write ghost stories. So anyway, the idea behind solar geoengineering is to produce a man-made version of a volcanic eruption. Specially designed aircraft would fly high up into the stratosphere and release either sulfur dioxide or some other reflective material. The particles would drift around, and just as after a volcanic eruption, they would reflect sunlight and cool the Earth. And in this way, the artificial eruption would offset the warming effect of dumping CO2 into the troposphere, or at least potentially could offset some of that warming. Now, one side effect of doing this would be to alter the color of the sky. The sky would become whiter, which is why I called my most recent book Under a White Sky. If messing with the stratosphere to solve a problem created in the troposphere strikes you as scary, as kind of monstrous, or Frankensteinian, you're not alone. Many eminent scientists share your concern. Solar geoengineering has been described as dangerous beyond belief, as a broad highway to hell, and as unimaginably drastic. It even worries the very scientists who are researching it, like Frank Koich, the head of Harvard's solar geoengineering research program, whom I interviewed a few years ago. When I started this, I was perhaps oddly not as worried about it, Koich told me, because the idea that geoengineering would actually happen seemed quite remote. But over the years, as I have seen our lack of action on climate change, I sometimes get anxious that this might actually happen, and I feel quite a lot of pressure from that. Solar geoengineering may be a terrible idea, but it is an idea that is not going away. Going backward on climate change is somewhere between fantastically difficult, 10 million projects on the scale of Orca, and impossible. And so, like it or not, we find ourselves pushed forward towards schemes like carbon dioxide removal and geoengineering. Whether or not those approaches will work, whether we can intervene in time to counter the last interventions remains to be seen. Humans are very smart and very stubborn, but the world is very big and very complicated, and things rarely turn out exactly as people had anticipated. So the two stories that I've told this evening are in certain respects very different. One features toads and sugarcane and genetic engineering, and the other fossil fuels, volcanoes, and stratospheric engineering. But as fables, their lines are pretty similar. Both are morality tales about human actions that have had planet-altering consequences no one remotely intended. They are about our efforts to change the world one way that ended up changing it in a totally different way. They are stories of people trying to make changes to counteract the effects of these original changes. This is what makes them Anthropocene fables. In the Anthropocene, the human and the natural can no longer be disentangled. In the Anthropocene, there is no way backwards that isn't also a way forwards. Through my books and articles, I have tried to get readers to attend to this extraordinary moment in which we live. It is a moment that will be inscribed forever in the geological record and will have enormous consequences, both for our own species and for the millions of other species with whom we share the planet Earth. Humans now dominate the planet and are determining its future. But we are not fully in charge of the changes that we are making. On the contrary, the more we control nature, the less we are actually in control. I'm going to end this evening with a quote from an American geologist, Marcia Bjornrud, who has written about this subject. The irony of our oversized impact on planet Earth, Bjornrud has written, is that we have put nature firmly back in charge with a still unpublished set of rules that we will simply have to guess at. Thank you very much.